Hello children, I am going to continue trigonometry for class 11 students. This is 14 number question. If sin theta is equal to 15 by 17 and cos phi is equal to 12 by 13, find the value of this, where theta and phi lie in first quadrant. So just create first quadrant. This is your first quadrant. Do the two triangles in first quadrant. Theta and phi both are belonging to first quadrant. Sin 15 by 17, cos 12 by 13, phi. Now find the value of base for this. The base is 17 square minus 15 square, this is 8. Likewise find perpendicular for this. Perpendicular is 13 square minus 12 square, this is 5. After that you can find the value of sin theta plus phi. Write sin A into cos phi, sin theta into cos phi plus cos theta into sin phi. You write the value from the two figures. Both figures are in first quadrant, so all are positive. Write the positive value. Sin theta 15 by 17, cos phi 12 by 13, cos theta 8 by 17, sin phi 5 by 13. The sign scheme positive, 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 positive. All the values will be positive. Simplify to get the answer. Likewise cos theta minus phi. Again cos theta minus phi is cos theta into cos phi plus sin theta into sin phi. Now put the values as you have put above. From using this figure, all the values are positive, 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 positive. In first quadrant, write the values and simplify to get the answer. Now tan theta plus phi, write the formula, and all the values are positive. So write 15 by 8 plus 5 by 12. See the figure and write the values. Simplify it to get the answer. So on simplification, from this step we get this. After this. So the final answer is 220 by 21. Now see 15th number question. Theta and phi both in second quadrant. So do the two triangles in second quadrant, and since the side of triangle are always positive, so never take side negative. Sin theta, this is for theta 3 by 5. Find the value of base 4. Likewise cos phi 12 by 13. Find the value of perpendicular. So we have got the three sides. After that you can find all these values, but remember the sign scheme. The sign scheme is sin theta plus phi, sin theta into cos phi plus cos theta into sin phi. Sin is positive, so write positive. Then cos phi negative, cos is negative in second quadrant. Again cos is negative in second quadrant. Sin phi. After that sin is positive, so positive we have written. Now see sin theta 3 by 5. As in class 10, you can put the value and simplify to get the answer, but never forget to write the sign. Similarly cos theta plus phi, cos A into cos B minus sin A into sin B. Sin A, in place of A and B, theta and phi have been written. Now write the value and simplify to get the answer. 16 number question. Theta and phi both are lying in fourth quadrant. So do the triangles in fourth quadrant. Write theta and phi. Remember it that cos theta is positive in fourth quadrant, but sin is negative. So sin negative, cos positive, sin negative. After that the values should be taken from theta. For theta this triangle is considered. For phi we use this triangle. Put the value, simplify to get the answer. Similarly cos theta minus phi, put the value and get the answer. Again this is 17 number question. Cot alpha half sec beta minus pi by 3. Alpha belonging to pi to 3 pi by 2. Pi means 180, 3 pi by 2 means 270. So 180 to 270 is the third quadrant. So alpha should be taken in first quadrant, sorry, alpha should be taken in third quadrant and beta in second quadrant 90 to 180. So this is 90 to 180 in which we have taken beta, triangle related to beta. Write the value cos alpha base by perpendicular, so 1 by 2, 1 is the base, perpendicular is 2. Find this, you know how to find out hypotenuse. After that, again in case of this beta 5 by 3, find perpendicular, you know how to find perpendicular. After that, remember the sign scheme, sin alpha plus beta, sin A into cos B plus cos A into sin B. Sin alpha is taken from third quadrant, so this is negative. Beta is taken from second quadrant, in second quadrant beta is negative, so both are negative. Cos alpha is negative in this quadrant, write the sign. And then sin beta is positive in second quadrant. After that, put the value as you are putting in class 10 and simplify it. Similarly, the sign scheme must be followed and the two triangles are used to write the values. Similarly, we can get tan alpha plus beta with sin tan alpha is in third quadrant where tan is positive, but beta is in second quadrant where tan is negative. So the values are substituted with sign scheme, and on simplification we get 2 by 11 as your answer. Now this is very important question for exam point of view. Tan 56 is equal to this, we have to prove. Starting from 56, we need 11 degree, so it should be degree. We need 11 degree, so write 11 plus remaining 45. 11 plus 45 makes 56. So the problem will be designed in such a way that 11 and 45, 11 is your requirement and 45 you know. After that, expand this by tan formula, and after that change it to sin and cos. Tan 45 1 by 1, simplify it, the denominators are cancelled and we get the RHS proved. This is the most important. Infinity stands for the infinite power, V for very important, infinite. The question is very popular from previous many years in mathematics. Tan 70 is equal to tan 20 plus 2 tan 50. Start from 70 degree is equivalent to 20 and 50. Why we written 20 and 50? Because we need 70, 20 and 50. So 20 and 50 makes 70. After that, taking tan both sides and according to tan formula expand this. After that, cross multiply tan 70 into 1. Tan 70, tan 20, tan 20, tan 50. After that, this tan 20 plus tan 50, cross multiply. Remember from class 10, tan 17 to tan 20, both are complementary angle, so the answer is 1. So this part will turn to 1. We are left with tan 50. Transfer this tan 50 to right side and your problem is answered. So tan 50 becomes 2 tan 50. This is the most important. Likewise, 20 is the most important problem. Cot 2x cot x minus cot 3x cot 2x minus cot 3x cot x is equal to 1. Again we need 2x, x and 3x. 2x, x and 3x. So we know 2x plus x makes 3x. After that, cot is requirement. So taking cot both sides. And using this formula of cot A plus B, cot A into cot B minus 1 by cot A plus cot B, write according to the formula and cross multiply. Transfer 1 to that side, right side, and transfer the two right terms to the left side. The proof is ready. This is question of exercise 2B of R.S. Agrawal. Prove that tan pi by 4 plus x by tan pi by 4 minus x is equal to this. Now we are starting from LHS. Break tan pi by 4 plus x, tan pi by 4 plus tan x by 1 minus tan pi by 4 into tan x divided by tan pi by 4 minus x, tan pi by 4 minus tan x by 1 plus tan pi by 4 into tan x. Now tan pi by 4 is 1. So 1 plus tan x, 1 minus tan x. Tan pi by 4, 1 minus tan x, 1 plus tan x. So on multiplication we get the RHS, the proof is ready. Again, tan 54 is equal to this, it has to be proved. Now starting from tan 54, this is equal to 10, 9 degree is the requirement, so remaining 45 is left. You know 45 degree values and 9 degree is the requirement. So we have started from 9 and remaining 54, both makes 50, 9 and 45 both makes 54. Again break this by 10 formula, and this is coming, and after that convert it to sine and cos and take LCM and simplify it to get the value this. Earlier I have already done this. Now in case of 10th number, tan 37 is equal to cosette minus sinette by cosette plus sinette. Now break 37 in two parts, 45 minus 8 is the requirement and 45 you know. So break by 10 formula, after that put tan 45 1, change to sin cos, again you are getting the RHS. Next, sin x 1 by root 5, sin y 1 by root 10. Then prove that x plus y is pi by 4. This problem is difficult because the given informations are related to trigonometry, sin x, sin y, but you have to prove algebraic proof. So in place of proving x plus y is equal to pi by 4, you mention sin x plus y is equal to sin pi by 4. Take sin both sides, and sin pi by 4 is 1 by root 2. Only then you can successfully give the proof. Create the second part yourself. Either you can take sin both sides or cos both sides or tan both sides. See the book once more or follow from this. You cannot prove this algebraic statement unless you use sin both sides or cos both sides or tan both sides, any one. Then start sin x plus y, sin x into cos y, cos x into sin y. There is no any problem of quadrant 1 by root 5. You can find successfully the value 2 and 3 by Pythagoras theorem. After that no quadrant is mentioned, so put the value, all values will be positive and simplify to get the answer. Next, tan x 13 by 14, cos y 1 by 7. Create two triangles anywhere not in quadrant. Again we have to prove the algebraic statement. So again use sine both sides. Sine minus pi by 3, sine out, sine 60. So this is minus root 3 by 2 to be proved. Now cos x 13 by 14, x 13 by 14, find the value of perpendicular. Likewise cos y, y 1 by 7, find the value of this. You know how to find by Pythagoras theorem. After that continue with sin x minus y. This is the requirement. Sin x minus y is equal to putting the value, and we are getting error. It means either there is error in the problem, so due to the error anywhere in the problem, the proof is not conducted. Don't be bothered. You have proceeded according to the instruction and according to the mathematical rule, so you can write error finally. The proof is not conducted. Next, 19. The question number 18, proof is full of errors. So try to, you cannot try, just keep it here and stop. Now this, prove this. Pi by 4 is taken as 45. Now break by sin a into cos b plus cos a into sin b, sin a into cos b plus cos a into minus cos a into sin b. Then both are cancelled. Negative positive cancels each other. So the same thing, sin 45 cos x, sin 45 cos x, 2 times we are left with, and write the value. 2 is 2, 45 sin 45 1 by root 2 cos x. Put the value. 2 can be written as root 2 into root 2. 1 root 2 cancelled, so the proof is ready. Again, this is the long question. 2 sin 5 pi by 12 cos pi by 12. Immediately convert pi to the degree. In terms of degree, this is 75 and this is 15. You have to prove that this is equal to 2 plus root 3 by 2. Sine 75, first of all, sine 75 cos 15. Earlier I have taught you how to find sine 75 and cos 15. Get the two values and put in this. Put here 2 sine 75 cos 15. Put the value and simplify. We get back the same proof as the requirement. So thank you students. Wait for another video. Thank you very much. I am going to over.